they give us the equation y equals x cubed minus 2 x squared plus x plus 1. And so when they want the horizontal tangents, can somebody explain to me what that process looks like, what we need to do to find the horizontal tangents?
Multiply.
Well, what we're looking for is y prime equaling 0.
Basically, like, factor it out.
So first thing we need is y prime. So this becomes 3x squared minus 4x plus 1. That's y prime, right?
Show.
Okay, so now I need to set this equal to 0, right?
Of course.
Now, this might be factorable. I'm hoping and praying that it is. So to just guess and check, well, this has to be 3x, and this has to be x. And this has to be 1, and this has to be 1.
Wait, how do you know it has to be 1?
Because it does.
It's not.
Oh, because...
What if I do this? What if I do minus 1 minus 1? This becomes negative 3x, and this becomes negative x. Hey, what's negative 3x minus another x? 4x. So this is this, right? So then what I got is 0 is equal to 3x minus 1 times the quantity x minus 1. So 3x minus 1 equals 0, x minus 1 equals 0. And that means that this would be x equals 1/3. And this is x equals 1.
Wait, isn't it like x plus 1? Or oh, you put negative 1. Oh. Okay.
I skipped some steps. Does that make sense? I know I went kind of quick, but I'm trying to cover. Do you guys understand what we did? Let me give you a summary real quick, okay?
Wait, I don't, like, can you explain, like, the box thing one more time?
Okay, shh. Okay, here we go. Let me explain it to you. The book says we need the horizontal tangents. Horizontal tangents means that the tangent line is horizontal. That means that the slope is 0. So the derivative of our function equals 0 at some value for x. So the first step is to take our function of y and take the derivative. We use the power rule because it's a simple polynomial. It's a third degree polynomial, so the derivative is a second degree polynomial, which is a quadratic. So we should maybe expect 2 possible zeros. So now we have a quadratic 3x squared minus 4x plus 1. We're hoping and praying that our text is merciful and gives us a factorable quadratic. So then we use the guess and check method. Now when we do the guess and check method for factoring quadratics, I need the first term and the last term, and then I guess and check what goes here and here and here and here, such that these two terms, when they combine, equal my middle term. So this is 3x squared. It's a prime number. To get to x squared, I need an x and an x. And 3 is a prime number, so it has to be 3 and 1. Now 1 is, technically, I guess you could call it a prime number, but we don't think of it. But the factors of 1 is 1.
And 1.
Yeah. 1 multiplicity 2. So I have 1 and 1 here, but then I notice that my middle term is 4, but it's a negative 4. So that means this, one of these ones has to be negative, but how do I get a positive 1 here? Well, I have to have a negative 1 and a negative 1. So at this point, I'm still guessing. Then I multiply everything out through the grid. Turns out that 3x minus 1 times x minus 1 does in fact equal 3x squared minus 4x plus 1. So these are my two factors of that quadratic. Set both factors equal to 0, solve for x, and those are the zeros
Of the function.
of the derivative function.
Prime.
And so y prime is equal to 0 when x equals 1/3 and x equals 1. Does that make sense to you guys?
Yes, sir.
Okay, let me stop recording.